Okay, so here we're shown a circuit used for domestic lighting and we're being asked to explain an advantage. So what is the advantage and why is it that this circuit gives us that advantage? So the thing to note here is that this is a parallel circuit, and the main advantage of parallel circuits is that the lamps can be controlled independently. So they do not depend on each other. You can have one on and the other off. It also means that if one were to break, the others would remain functioning. So that's the first thing. The advantage is that the lamps can be controlled independently. And as we've said, the reason for that is that it is a parallel circuit. Then give the name of the charged particle that moves in an electric current. That is the electron. Here we have a show that question. So when we're asked to show that, what that means is we treat the power as unknown, and when we get our final answer, it will be close to that value of 5 watts. So to do this, we need power is current times PD. We can take that from our formula sheet. Now we can see from the circuit diagram that our current in lamp 1 is 22 milliamps. So the important thing to notice here is that a milliamp is 1,000th of an amp, and therefore in order to get from milliamps to amps, you divide by 1,000. So when we plug that in, we have 22 milliamps is equal to 22 times 10 to the minus 3 amps, and we have a PD in each bulb of 230 volts because it is a parallel circuit. When we do that, we get an answer of 5.1 watts, and that is indeed almost 5 watts. Calculate the energy transfer by the lamp when it is on for 30 seconds. So from our formula sheet, we know that power is the rate of energy transfer, so energy divided by time. So if we rearrange that to give energy is power times time, we can then take our value from part 2 above, the 5 watts, and we multiply that by the time, which is already in seconds, so no conversion there. When we do that, we end up with a value of 150 joules. Remember, of course, you can use the value of 5 watts or you can use the 5.1 that you got when you actually do the calculation in part 2. State what's meant by the term voltage. There are 2 ways to do this. You can either take the formula and you can quote it. So you can write out the formula and then you can simply make a note that E is the energy and Q is the charge. That is perfectly acceptable. Or you can use that formula to try and put it into words, because the correct term for voltage is the energy that we have per unit of charge in a circuit. Now switches 1 and 3 are closed, so lamps 1 and 3 are lit, but switch 2 is open. Calculate the current in the main supply. So that's the current that is being supplied to the whole circuit. Because we have a parallel circuit here, current splits in a parallel circuit, and therefore the total current in the circuit will be the sum of all the individual branches. Now we've only got branch 1 and 3 to consider, so branch 1 was 22 milliamps and branch 3 is 17 milliamps, and when we add those together we get a total current in the circuit of 39 milliamps.